We're addressing the installation of a high-voltage electrical supply to a sand barge located in a pond at an industrial site. The owner is proposing a 12 kV, 3-phase connection using a 15 kV, 3-conductor cable with a ground shield. The setup involves an overhead section from a pole at the shore to a flexible cable supported by floats leading to the barge. A transformer on the barge will step down the voltage to 480 volts, which will then feed a 600 amp motor control center, or MCC. Let's delve into potential concerns and crucial considerations for this project. First, consider the electrical design. It's vital to ensure proper voltage regulation and stability, especially when the barge's electrical loads are significant. Implementing voltage regulators or surge protection devices will safeguard equipment against voltage fluctuations. Carefully calculate and mitigate voltage drop throughout the overhead line and flexible cable. A well-designed grounding system is essential, providing robust protection against electrical faults and lightning strikes. Next, focus on the overhead line installation. Ensure poles are placed strategically and line clearances are adequate, especially considering the line's passage over water. Use galvanized steel or aluminum conductors and insulators specifically rated for outdoor use and the harsh environmental conditions. Install lightning protection devices to minimize the impact of potential strikes on the system. The flexible cable installation requires meticulous attention. Choose a flexible cable specifically designed for marine environments, ensuring it's rated for the required voltage and current carrying capacity. Secure and protect the cable adequately to prevent mechanical damage and water immersion. Provide thorough training to personnel regarding the proper handling and maintenance of this flexible cable. The transformer selection is also crucial. Determine the appropriate transformer size, considering its kilovolt amps rating, impedance, and winding configuration to precisely meet the barge's anticipated electrical load requirements. Ensure the transformer has adequate cooling and environmental protection, designed to withstand the marine conditions. The motor control center design must address the specific requirements of the barge's electrical system. Include overload protection, short-circuit protection, and a reliable grounding system for safety. Other considerations are just as vital. You must obtain all necessary permits and approvals from both local authorities and the utility company before commencing any work. Prioritize safety by establishing clear safety protocols for the operation and maintenance of the entire electrical system. Evaluate the potential environmental impact of the installation and take steps to minimize any adverse effects on the surrounding area. Regular maintenance is paramount. Develop a comprehensive maintenance schedule to routinely inspect and service all equipment, including the overhead line, flexible cable, transformer, and motor control center. 1. Consider consulting with a qualified electrical engineer who has experience in marine electrical systems. 2. Use high-quality components and materials to ensure long-term reliability and extended service life. 3. Rigorously test and commission the entire system thoroughly before placing it into operational use. 4. Comprehensively train personnel on the safe operation and maintenance procedures for the entire system.